them is because they are divisible by a perfect square. Let's list the perfect squares again at the top of our paper. So 1 is a perfect square, 4, 9, 16, those are perfect squares. This is page 38. 38 in the resources in front of your packet. Give me the next perfect square. 25. Give me the next one. 36. The next one. 7 squared is 49. 8 squared, 64, 81, and 100. And maybe I know 121 and 144. So perfect squares, if you don't know what they are, you are going to write those down on your paper before you start trying to simplify radicals. So now we are looking at the square root of 24. So I'm looking up here, which one of these numbers is a factor of 24? Well, 25 is bigger, so it can't be 25. Would 16 go into 24? No. Does 9 go into 24? No. But 4 goes into 24 evenly. So what you do is you rewrite the square root of 24 as its factors. The square root of 4 is coming from our list, and the square root of 6, 4 times 6 is 24. So this is called the product property of radicals. I can take the square root of 24 and write it as the square root of 4 times the square root of 6. Let me just show you on my calculator that those are equivalent. So if I take the square root of 24 and I take the square root of 4 and multiply by the square root of 6, I see I get 4.89. So, yeah, the square root of 4 can be simplified, right? The square root of 4 is exactly 2. So I can write my solution as 2 times the square root of 6. Let me prove to you that that's the same answer. 2 square roots of 6. So whether I write the square root of 24, root 4 times root 6, or 2 root 6, they're all equivalent. They all equal 4.89897946 irrational. But this is called reduced radical form. This is what we're going to try to practice a little bit. 72. So I go all the way to the end. 81 is bigger. 64 does not divide in. 49 does not divide in. But 36 goes into 72 how many times? 36 times 2 is 72. Now let's pretend, well, let me finish this one first. What's the square root of 36? 6, and then the root 2 stays trapped. So 6 root 2 is the answer. But what's another factor of 72? Do you see another factor up here? 9. So let's pretend I thought the square root of 72 was equal to 9 times 8. Am I wrong? Well, that's 3 root 8. 3 root 8 is a different answer than 6 root 2, but that's because root 8 could have gone a step further. What are the perfect square inside of 8? So I could do square root of 4, square root of 2 to get 8. And what's the square root of 4? So isn't 3 times 2 6 root 2? So you do get the same answer, but look, I had to do all these extra steps. It's easier to find the biggest factor first. That's a perfect square. So that's why I always start up here at the end. All right, 81 is bigger than 72, 64 no, 49 no, 36. So always start at the end of the row and work backwards. Don't start small and go big. All right, what about number 3? What perfect square goes into 300? 100, 25 also does. 4 also does. No, 4, yeah, 4 does, 175. We want the big one, right? So 103. So your answer is 10 root 3. So we're going to try practicing reduced radical form when we do this strategy today. So let's review really quick the quadratic formula. You got to wait till tomorrow, though. Make sure you're here. Be here or be square. Get the pun? Square roots. Square root things. All right, solve quadratics by taking square roots. Okay, so when do I want to use this strategy? I want to use the strategy when things are not easily graphable or easily factorable, right? You can't use it when there's an x term, only when there's an x squared term. So if you notice, all of these just have x squared in them. They don't have an x term. And it says, this is very important. When you take the square root of both sides, you make your solution positive or negative. So this can be confusing for people. If I just ask you, what is the square root of 16? What would you say? 4. Okay, because 4 times 4 is 16, right? This is called the principal square root. So if you do it on your calculator will tell you this answer. Let me ask this in a different way. What number squared will give me 16? What would x equal in this equation? Is there another number that when you square it, you get positive 16? What about negative 4? Is negative 4 times negative 4 16? No. Yes, it is. So there are two solutions, but when we take the square root of a number, we just say the principal square root, the positive square root. But we need to be on the lookout for two possible answers because most quadratics have how many x-intercepts? Most quadratics have 2 x-intercepts. So you've got to get two solutions to most of these. All right, so your process is x squared by itself. How am I going to get x squared by itself in this equation? Add 7 to both sides of the equation. Did I get x squared by itself? Okay, step 2, take the square root of both sides of the equation, right? How do you undo a square? You square root it. Just like how do you undo addition? X plus 3 equals 7. You use subtraction, right? How do you undo multiplication? You use division. So how do we undo a square? We take the square root of both sides of the equation. X could be 6 or negative 6. So that's when you need to write your two solutions. All right, example 2. How do I get x squared by itself in example 2? What would you do first to both sides? Divide by 5 on both sides of the equation. So you might have to do 80 divided by 5 on your calculator. Comes out to 16. All right, what do I do next to both sides of the equation? I take the square root of both sides and I get x equals 4 or negative 4. Turning this off now. Smells very peppermint here. I wonder if I have to unplug it. Oh, I need a battery. Maybe come with that. Ooh. All right. Whew, let that peppermint dissipate a little bit. Okay, next one. How do I get x squared by itself in example 3? First step would be, this is just algebra. 5 to the other side. 3x squared now equals 36. Divide by 3 next. So when I divide by 3 on both sides, x squared equals 12. All right, now what do I do to both sides? Take the square root of both sides. I'm going to have to do reduced radical form. Sometimes I just write plus or minus instead of writing 6 or negative 6. You could write plus or minus. All right, what are the perfect squares? 4, right? What goes into 12? 4 goes into 12. So I'm going to rewrite this as the square root of 4 times the square root of 3, because that's equivalent to 12, right? 4 times 3. The square root of 4 I can take. The square root of 4 is 2, and then I write the root 3 after it. So my answer is plus or minus 2 root 3. If you don't like that format, you could write 2 root 3 or negative 2 root 3. I just think that's more to write. So if you like the plus or minus, when you take a square root, you get plus or minus the answer. That might help you not forget. Okay, and then the last one. I put this one on here because students see this square and they want to FOIL it out. And I'm telling you, don't FOIL it out. What do I do first to get x? This is the whole term right here is x squared. So what do I do to get it by itself? Divide by 2 first. X minus 2 squared equals 20. What would I do next? Huh? No, we don't want to add the 2 yet. It's stuck in the parentheses right now. So this is like x squared. So what do I do to both sides to get rid of the square? I take the square root of both sides. That's going to give me just x minus 2. And then equals plus or minus. What should I break up the 20 into? What are the perfect squares that go into 20? William? So this is really the square root of 4 times the square root of 5. What is the square root of 4 equal to? 2. So this is really 2 square roots of 5. And I don't have x by itself yet. So what would I do to get x by itself? Just add 2. When you add 2, you don't want to add it inside this radical. So x equal plus or minus 2 square roots of 5 plus 2. If you had to type it into your calculator to get a decimal, you would do 2 square root of 5 plus 2 and negative 2 square root of 5 still plus 2. So the plus 2 gets added to both of them. So that's the strategy. Get x squared by itself and take the square root of both sides. So we're going to try a couple practice of those. And that's the strategy that's on your homework tonight. So we're just going to do, it's only one page anyway. So if you look at 1 through 12, let's do 1 and 7 again on this page, and then you kind of try the rest. On the top, all you need to do is simplify the radicals. This is page 307. 307, solving by square roots. So let's set up 2 examples on this page, and then I'll give you about 10 minutes to try the other problems. And then we're going to try a group problem today called Spirit Socks. All right, square root of 40. First one up. What do I break up the 40 into? What's a perfect square? So remember, you could keep that list kind of in front of you. 100, no, 81, 64, 49, 36, 25, 16, 4, 3, 2, 1. So if you look, you got to be down here first because you only get 40. Is 40 divisible by 16 or 9? I think it's only divisible by 4. So you're going to write it as the square root of 4 times the square root of 10. Then you're going to take the square root of 4. So your answer to number 1 would be 2 root 10 is how you say it. 2 square roots of 10. 2 times the square root of 10. All right, let's go down and try number 8 down below. That way you've got one set up on your page to use as a model. How am I going to get x squared by itself in number 8? First, add 32 on both sides of the equation. So I'll have 2x plus 3 squared equals 32. What would be my next step? Divide by 2. So x plus 3 squared now just equals 16. Take the square root of both sides. X plus 3 equals 4 or negative 4. I'm going to write them like this. Oops. Because I actually need to figure out what x is, because this is a perfect square. So either 4 or negative 4. How do I get x by itself? Subtract 3. So you're going to subtract the 3 here, and you're going to subtract the 3 here to get your final answers. What is 4 minus 3? 1. And then what is negative 4 minus 3? Negative 7. So on this problem, you actually don't have a reduced radical. You've got 2 integer solutions, 1 and negative 7. That looks a little bit better than writing plus or minus 4 minus 3. Like, what is that? That's just 4 minus 3 and negative 4 minus 3. So this is the way I want you to write your answer if it's a whole number. All right, you try the other like 10 problems. Take like 10 minutes to try those 10 problems, and then we'll kind of put up our answers and try starting into a group problem we might have. You're looking for not only factors of 98, but factors that are perfect squares. So you write the perfect square first and the non-perfect square second. So in this case, it would be 49 times 2. And then I take the square root of 49. That becomes 7. And then the square root of 2 stays as the square root of 2. So 125. It's 25 times 5. And now I'm going to take the square root of 25. So the square root of 25 is 5, and the square root of 5 remains as the square root of 5. So 150, you can't use 15 times 10. Neither of those are in our block list up here of perfect squares, right? So I want to use what number? 25 for number 4. 25 times 6, right? So I'm going to take the square root of the 25 and the square root of the 6. And I'm going to leave my answer as 5 root 6. And if you're on a quiz and you feel like you want to check if you got the right answer, take the square root of 150 on your calculator and take 5 square roots of 6 on your calculator, and they should come out to the same number if you've reduced it. All right, 120. I can't do 12 times 10. Those are not perfect squares. 12 and 10 are not in my list. I can do 4 times 30. And I put the 4 first because I'm going to take the square root of the 4. So I get 2 root 30. So 2 root 30 is the reduced radical. And then 27 is 9 times 3. So 3 root 3 should have been your answer for number 6. So we're going to come back to that again tomorrow, because when we solve with the quadratic formula, we can also put our answers in reduced radical form. All right, on number 7, you should have added 2 to the other side to get x squared equals 44. Then, when you take the square root of both sides, you should have used 4 times 11 to do the reduced radical. And I bet some of you forgot to write plus or minus 2 square roots of 11. So if you forgot to write plus or minus, make sure you go back and write it. You have to have 2 solutions, 2 x-intercepts. All right, number 9. Add 23 to both sides. How can I reduce 75 if you didn't get there yet? What would you use? 25, right? I'm taking the square root. 25 times 3. I'm not quite finished yet. X minus 1 equals, the square root of 25 is 5, square roots of 3, add 1, and make sure to write plus or minus. I already forgot to write plus or minus. Plus or minus 5 root 3 plus 1, right? I would move the 1 to the other side. So there's a lot into this question, right? You need a plus or minus sign. You need the 5 root 3 because that's the reduced radical, and you have to remember to add 1 to the other side. So it's going to take a little bit of practice. Okay, there's a problem that happens on number 10. You should subtract 80 to start. So you have 2 of these things equals negative 80. And then your second step is what? Divide by 2. X minus 1 squared equals negative 40. When I go to take the square root of both sides, a little red alert should pop up in your brain. Can I take the square root of a negative number? If you're not sure, go on your calculator, take the square root of negative 40, and it says non-real answer, which means it does not have a real x-intercept on the graph. We're not going to learn about complex numbers, imaginary numbers, I. but advanced will and pre-calculus will. So you'll see them again if you end up taking a later math class. But this is just no solution for us, which means my original quadratic, you don't have to graph this, but if I put this 2 times x minus, oh, actually, I don't need to graph it because where does the vertex move? Right 1 and up 80, and it's concave up. So I'm never going to hit the x-axis with this quadratic, right? Because I went up 80 and I'm concave up. All right, number 11 tripped some of you up because of the fraction. When you divide by a fraction, the answer is not 5. So when you divide by a fraction, don't be shy. Flip the fraction and multiply. You're really multiplying because if you multiply by 2, see how 2 times 1/2 is just 1, so they would cancel out? So you're really multiplying by 2. So you get x plus 3 squared equals 20, not 5. So if you got that one wrong, please fix it. But you're going to take the square root of both sides and simplify the square root of 20 this time. Have we done the square root of 20 yet on this page? Maybe not. What's the perfect square that's inside 20? 4 times 5. So 2 root 5. And then I'll just subtract 3 to finish the problem. I'm just going to cancel it and move it to the other side as a minus 3. So plus or minus 2 root 5 minus 3. And then we end with an easy one. Why is 12 easy? What happens when you add 23 to the other side? You get 0. Are you allowed to take the square root of 0? Yes, you are. The square root of 0, if you're unsure, is 0, because 0 times 0 is 0. So if x minus 1 equals 0, do I have to write plus or minus 0? 0 is 0. But I just have to add 1 to the other side. So this only has one x-intercept. Why is that? Because when I graph this function, the function is x minus 1 squared. Because I would add this 23, this would be 0. So that just goes right 1, right? And if you just go right 1, your x-intercept is here, and you're opening up from that point. So you only have one x-intercept. All right, so we're going to kind of set that aside for today. You have homework on 3